डायसन का ये माना जा रहा था कि ये सबसे ब्राइट कॉमेट हो जाने वाला है जिसको नेकेड आई से भी हम लोग देख पाएंगे। यदि ये सूर्य के नजदीक आने वाले अपने क्रिया को संभल पाता, उसके बिना टूटे हुए बच पाता, बट वास्तव में ऐसा हुआ नहीं। ये जब सूर्य के नजदीक आया तो इस पे टाइडल फोर्स और वहां की जो ग्रुप और हीट के कारण टुकड़े टुकड़े हो गए और समाप्त हो गया। और उसके सूर्य से जब दूरी तरफ जाने लगा तो बिल्कुल नहीं दिखा, लगभग ऐसा हो गया, जबकि ये उस टाइम पे सबसे ब्राइट कॉमेट होने की संभावना। इस पर हाँ, how the solar wind affects the Earth's atmosphere. Right. His question is how the solar wind affects the Earth or our environment or our solar planet. Basically, as I mentioned, that the solar wind has two things. One, that it has a plasma which moves with a velocity of 3 to 3000 kilometers per second, very high velocity, and it also has a magnetic field. So it is a magnetized plasma which comes with a very high speed. Fortunately, our Earth also has a magnetic field. And our Earth has a magnetic field which is almost dipolar in nature. उससे भी नहीं चला। हाँ, तो इंसान हमारे पर कंप्यूटर नहीं। ठीक है। लेक्चर के बाद I have a laptop. Maybe it is in that. Okay, doesn't matter. वहाँ पर वापस आती। The meantime, let me explain to you. So, the magnetic field of the Earth makes a dipole. Now, when the solar wind comes, it hits the magnetic field from one side and compresses that side. And the magnetic field of the other side gets expanded by that reaction. So, but then it still becomes a magnetic bottle around the Earth. So, major part of the solar wind does not enter our atmosphere or our environment, our magnetosphere. But some part which leaks through two regions, one is the North Pole and the South Pole region, or the extended tail that the Earth's magnetic field has, then because magnetic field on that end becomes very weak and the field line open and close there, so some material from the solar plasma enters from there. And these affect our magnetic field, our ionosphere, our communication, and it also creates a very beautiful phenomena which is seen only in the northern part and the southern part of the Earth called aurora. A different color, red, green, blue, sort of dancing lights in the night, and sometimes it can be so bright. And whenever there are these kind of storms like the one that was shown in that picture, that suddenly more material comes out. When this more material with more velocity and plasma comes out and interacts, at that time there has been occasions where this aurora could be seen for up to lower latitude as well, mid latitude. Of course, it can never come or can never be seen in any part of our country because we are almost very close to the equator. Here we are totally shielded by the magnetic field of the Earth. There is no direct effect of solar wind on this region, but the polar regions get affected. But then those polar regions in turn are connected, so later on we also get affected. So it affects our communication sometimes. It also affects the polar, the pipelines of the higher leg, northern and the southern. Southern, of course, there is not much population, but the northern has a lot of population in like Europe, Canada, and the northern part of North America. They have many of their systems fail, transformers fail. So that is due to the solar. So solar wind as such affect our environment, our system, but large effect of this is not felt because Earth has a very good magnetic field which provides a bottle around us, a magnetic shield. So it does not allow major part of the solar wind to enter. Like Mars, I was telling that Mars has another difference from our Earth, that it does not have a strong magnet, it has a very weak magnetic field. So the magnetosphere is weak, thereby the solar wind almost reaches the entire surface of Mars, and because solar wind is a continuous pressure, continuous plasma that comes and then flows out all the time, so it also takes away material from there. So it removes the atmosphere of planets of that kind where the magnetic field is not there. So all these things, the nature provided to the Earth, of course it's not that we have made, it is provided by the nature in such a way that we are protected and we are given as much heat, as much cold, as much magnetic field that it sustains our existence on the Earth. But still it affects. Next slide please. You can. So this is the photograph of this comet Sun, which was supposed to have been the very most bright comet of the present time. And so here you see that it has a very large tail. It's taken by a telescope, not by a naked eye, or a smaller telescope. And you see that this tail has lots of knots and sort of irregularities all around everywhere. So this is a very long tail. This was just before, on 28th, this movie that I was to show was of 28th November when it was closest, and there the comet just came very close to the sun, and the tidal force and the heat of the sun destroyed it completely, and you could see in the movie when it goes towards the end, it almost, that is nothing that you can see. Of course, the path of ISON will still have material, and whenever Earth or any planet goes in that orbit, passes that orbit, or comes very close to that, it will be able to get the material from there, and those materials will then get affected by that planet or whatever that is, and then will eventually hit and make what is called so-called the shooting star or toothed tare. So that is not basically tare, it's a material, leftover material of comets caught by the gravity of our planet or the planet on which they land. There are also lots of meteors that fall on moon, but because there is no atmosphere on the moon, so this friction does not take place. So they get heated, but not to that extent that they can be seen, that they appear almost like a breaking star. Whereas our atmosphere is fairly dense, and here the friction increases the temperature of this falling material to such a large extent that the material starts burning and splitting also, and then you could see that the kind of thing that we see in shooting stars. Next slide. So this is, in fact, ISON was supposed to have become even brighter than this comet, but this is the brightest comet of this century, called, now it is the other one, Hellboy. And here you can see the two tails very clearly. This is dust tail, and this is the iron tail of the comet. Iron tail is the tail which is created by solar wind, and dust tail is by light pressure, a light from the sun, because light provides a pressure and it pushes the neutral part of the core of the surrounding of the comet and makes this tail which appears white. And the iron tail is pushed by these two get separated only when the direction of solar wind is slightly different than the direction of the sunlight, because the direction of solar wind depends on the magnetic field. Whenever there is a boundary crossing, it will go from one side to the other side, and that's when there are occasions on a comet that both the tails get merged, and there are occasions that the tails get separated. And this comet, the specialty was, this had the largest nucleus. The solid part is estimated to be about 35 kilometers in diameter, whereas on an average, the comets that scientific world has studied, the average diameter is about 5 kilometers. So it is 7 times, one of the, it's the largest comet that the studies have so far been made. Next slide, please. There are 2 other comets shown here. One is this comet. This was certainly seen. It was not there, not visible to anybody before, but there was a total solar eclipse on 1st November of 1948. Total solar eclipse, when the moon covers the sun completely, and suddenly you start seeing the stars, or it becomes night like situation. And there, very close to the sun, there was a comet which had a tail like this. So this was seen only during the comet, and that's why this comet then was named as eclipse comet. Of course, this was not the only comet that was seen. There were others, but this was more spectacular. So this is named as eclipse comet. And here there is another comet called Lovejoy. And in fact, this is still visible, but not by naked eye. By the telescope, you can see this. And our observatory at Mount Abu is making some measurements of this and trying to study the properties of this dust tail, determining the size of the particles that are there in their distribution. And this is fairly close to Earth, and the tail is very large. Tail has a length of something like 87 miles. It's very, very large. And in fact, such a